Assalamualaikum warahmatullahi taala wabarakatuh, and a very good day to everyone. Okay, my name is Muhammad Fikri bin Muhammad Azam. My metric number is 182053. Okay, so my final year project title is Stability and Characterization of Nanographene Oxide, which is known as NGO, attached to the fluoronate F127, which is PF127, to simulate in Vivo and Vitro condition. Okay, so my supervisor is Dr. Faizah binti Muhammad Yasin. Okay, so now move to keywords. So actually there are 4 keywords in this project. So the first one is graphene oxide. So what is graphene oxide? Graphene oxide is actually compounds of carbon, oxygen and hydrogen in variable ratio. So as you can see in figure 1, it is graphene oxide structure. So the second keyword is fluoronate F127. Fluoronate F127 is non-ionic tri-block copolymers composed of PeO, PPO and PeO. So PeO is polyethylene oxide, PPO is polypropylene oxide. So the ratio of PeO, PPO and PeO is about 2 PeO ratio of 1 PPO. So fluoronate F127 also have molecular weight of 12,600 gram per mole. So as you can see figure 2, it is fluoronate F127 structure. Okay, next is in vivo. So in vivo is an experiment or testing that is done inside the living organism. In vivo is more expensive and time consuming. So next, in vitro. In vitro is an experiment that is done outside of the living organism. It is less expensive and quicker result. Okay, now move to introductions. Okay, so this is the different methods to synthesis graphene oxide. So as you can see in the figure 3, so there are 3 methods. The first one is Hammers method. Second one is improved Hammers method. And the last one is Hammers modified methods. Graphene oxide have been prepared originally using classical methods established by Brody, Staudenmayer and Hammers. So methods to produce GO, like I said earlier, is Hammers method, improved Hammers method and also modified Hammers method. So in this case, in this project, I preferred using improved Hammers method due to 4 main factors, which are simpler protocol, higher yield, no toxic gas evolution during preparation, and lastly, equivalent conductivity upon reduction. Fluoronate F127. Fluoronate is combination of polyethylene oxide, polypropylene oxide, polyethylene oxide, tri-block copolymers, which is in aqueous solutions. So here is the structure of fluoronate F127. Fluoronate F127 able to see damaged cell membrane with low toxicity due to its surface activity and also the absorption capacity into the bilayer of damaged cell. Fluoronate 127 is biocompatible polymers. Now, graphene oxide and fluoronate F127. According to Alejandro et al. 2016, graphene oxide has incredible application potential in the field of block copolymer, explicitly fluoronate F127, as a result of its high surface zone and sperry source. Moreover, fluoronate F127 present great bulk physical and chemical properties, for instance, straightforwardness and adaptability. Next, graphene oxide, an oxidized form of graphene, has been gaining significant momentum over the past few years for its application in the biomedical field due to the unique properties such as good water dispersibility and strong absorption capacity, according to Yan et al. 2011. Since GO-based material was first used to deliver water-insoluble drugs, much progress has been achieved for drug delivery due to Liu et al. 2008 and Zhang et al. 2012. So here example of graphene oxide with fluoronic F127 at the air-water interface. So this experiment occur in the air-water interface between non-covalently suspending graphene oxide in electrolyte solution has been explored using fluoronic F127. Fluoronic F127 approved by FDA for drug delivery due to efficiently disperse graphene oxide in cell medium in the presence of electrolytes. Fluoronic F127 can be applied to block the hydrophobic and hydrophilic of graphene oxide. So the method used is Langmuir monolayer. So this method to characterize the interaction by surface pressure area isotope measurements, stability, absorption, atomic force microscopy, imaging and infrared reflection absorption spectroscopy, or known as IRRAS. Now move to the experiment section. So GO is suggested to change the conformation of PF127 at the air-water interface and also drag fluoronic F127 from the interface to the butt surface. Atomic force microscopy, or known as AFM image, supports the assumption as GO and PF127 can be observed by spreading the surface solution outside the compressing barriers as shown in the picture. Next, we move to problem statement. Previously, graphene oxide produced by using dry method, which is chemical vapor deposition, which known as CVD. Although CVD can produce graphene oxide productively, but the production costs are very expensive and this method is quite confused. So next, the innovation of science and improvisation of engineering technology discover new method, which is new wet method. So this method has been decided that Hamer's method are example of cheaper and simpler methods to produce graphene oxide. So the method used was improved Hamer's method, and it is due to what I said earlier. Since graphene oxide produced in bigger size, it has low surface area. Apart from that, extra procedure need to do, which is make the size of graphene oxide become nano size. So no sonicator probe will be used in this case to make nano graphene oxide. Next, graphene oxide in biomedical application is its agglomeration or precipitation in electrolyte solutions, but fluoronic F127 is surfactant in the solutions. So the fluoronic F127 need to be decorated into the surface of nano graphene oxide to stabilize it. Besides, graphene oxide also toxic to the cell and need fluoronic F127 to stabilize in it, since fluoronic F127 is biocompatible polymers. Lastly, the interaction between graphene oxide and fluoronic F127 need to be identified, including their stability and also characterization either in vivo and vitro condition. There are some of things that need to be looked at. For example, their morphology, size, zeta potential, dynamic light scattering, and etc. Now move to objective parts. So the main objective is to synthesize and characterize nano graphene oxide functionalized fluoronic F127. So the sub-objective are to synthesis nano graphene oxide, and the second one is to synthesis fluoronic F127 degraded or functionalized with nano graphene oxide. And the second one is to evaluate the characteristic nano graphene oxide attached to the fluoronic F127 simulated in vivo and vitro condition. Now we jump into literature review. So, according to Jim and Novoselov 2007, graphene oxide is a 2D crystal structure formed by a flat monolayer of carbon atom arranged in a hexagonal lattice. Additionally, graphene oxide is much easier and cheaper to process and produce in bulk quantities, according to Marquez et al. 2010. As you can see here, figure 5, graphene oxide structure. Next, fluoronic F127 is often used in tissue engineering because of the commercial availability of a consistent product that will undergo a sol gel transition near psychological temperature and also pH, according to Clauda and Mikos 2008 and Lipens et al. 2013. Due to their amphiphyllate characteristic, fluoronic possess surfactant properties which allow them to interact with hydrophobic surface and biological membranes, according to Batrakova and Kabanov 2008. As you can see in figure 6, it is fluoronic F127 structure. Now we move to significance of study. So there are 3 significance of study in this project. The first one is learn the effectiveness of nano size instead of micro size. The second one is study the characteristics of fluoronic F127 functionalized with nano graphene oxide. And the last one is get to know the difference between Vivo and Vitro condition. Now move to methodology part. So here is overall method for this project. The first one is synthesized graphene oxide use improved Hamer's method. The second one is characterization of on the graphene oxide by using Raman spectroscopy. The third one is continue with nano graphene oxide sonicator probe, functionalize nano graphene oxide with fluoronic F127, and characterization to check the attachment of nano graphene oxide with the fluoronic F127. So now move to section A, which is synthesis nano graphene oxide. So these are the materials and chemicals that been used in this experiment. So these are the apparatus that have been used in this experiment also. So this is the method to synthesis nano graphene oxide. Now move to section B, functionalization of nano graphene oxide with fluoronic F127. So the material needed is fluoronic F127. So in this section, nano graphene oxide will involve physical mixings with fluoronic F127 at suitable or specific ratio. Section C, characterization in simulated in vivo and vivo condition. So in vivo condition will be evaluated in culture media and phosphate buffer saline, or known as PBS. So in vitro will be simulated gastric juice and simulated intestinal fluid. Now move to expected outcome. So there are actually 2 expected outcome throughout this project. The first one is be able to synthesis graphene oxide by using improved Hamer's method and continue to synthesis nano graphene oxide. And the second one is be able to know the stability and characterization of nano graphene oxide attached to the fluoronic F127. Okay, so this is the Gantt chart for semester 1. Okay. Next, we move to references throughout this project. So this is the continuation of the reference of this project. Okay, I think that's all from me. I hope you guys understand what I talk. Okay, thank you.